finally parsed. So within that, we also have levels of measurements, or different types of scales. And so there's 4 major types. There's nominal, there's ordinal, there's interval, and there's ratio. And so nominal and ordinal data, or scales, are how we measure qualitative data. So nominal and ordinal, we're going to discuss these in more detail, but they're less finely detailed than interview and ratioed scales, in that you can't make the same sort of statistical comparisons or analyses that you can make with interval or ratio data. And so with the nominal or ordinal, nominal is just naming a category, is just naming whether or not a person possesses a quality or characteristic. And ordinal provides rank information, but that is it. It doesn't provide any other way to meaningfully break that down. Quantitative data, though, can also be broken down into interval and to ratio data. And so interval and ratio are very similar, and so I won't get into those too much right now. But suffice it to say is that they have a scale. The scale has meaningful units. Those units relate uniformly across that scale. And you can meaningfully say things about central tendency and that sort of measures of descriptive statistics. So types of qualitative measures. There's nominal, like we previously discussed briefly, and ordinal. Those are the 2 major types of qualitative measurements. So nominal data, nominal levels of measurement, nominal scale. It classifies data into names, labels, or categories. And if we think about the example that I used earlier of eye color or gender, gender is a good example of a nominal level of measurement. And so when you have a nominal level of measurement, you're able to say that a person possesses that quality or doesn't possess that quality, but you're not able to say anything else about the relative worth, the relative value, or the relative possession or amount of a quality. You either have that quality or you do not possess that quality. And so when we think about the example of gender, if we want to pull up a quick little scale here and think about how people might identify in this class. So how do you see, what is your gender identity? And let's say in the class that we have 10 people that identify as male, 10 people that identify as female. We have 3 people that identify as transgender, 2 spirit. We have 2 people identify as 2 spirit, and we have 1 person who identifies as bigender, and 4 people identify as genderqueer. So however those individuals that they're self-identifying, however they're defining this characteristic or quality of being male, being transgender, being 2-spirit, however they're defining that quality, we can say that there are 10 people who identify as male, who possess whatever they're defining this quality as maleness. They possess that quality. But we would never be able to make any sort of, nor we would certainly want to, make any meaningful distinctions about, well, how do these relate together? They only relate together in so much as they're describing a gender, and they're describing how many people possess that quality of a gender. And so 10 people are yes, and then they are no to the rest of these categories. 10 people are yes to female, and they are no to the rest of the categories, and so on. So with ordinal levels of measurement, we can actually provide a little bit more information because it provides a rank order. And so the example that's provided here is grades. So with grades, if they're given an A, B, C, D, F, that is just going to provide you with ordinal information. So ordinal scales. When we have an ordinal scales, an example would be grades, right? So example grades A, B, C, D, and F. Because we can say that an A is better than a B, we can say a B is better than a C, but we don't know what the difference is between an A and a B. There's no meaningful unit of measure on this scale here. Is it 1 unit between A and B and 1 unit between B and C? Is an A twice as good as a C? We don't have any way to really know that. We just know an A is better than a B or a C or a D or an F. We don't know how much of that quality or quantity it possesses. And so it's really just going to provide you with a rank order. So ordinal scales provide rank orders. Another common example that you will see a lot are Likert scales. So there's a little bit of controversy because some people treat Likert scales as a different type of scale. But for the most part, Likert scales are more appropriately treated as ordinal scales. And here's the reason why. So let's think about if we have a question that says, how would you rate your experience with the Career Center? And we give the students the options of very good, good, average, poor, average, fair, and poor. Okay, so we give them that order. So in this scale, we can say very good is better than good, good is better than average, average is better than fair, fair is better than poor. But we can't fairly say what is the difference between very good and good. What is the quality of satisfaction with the experience that very good represents in comparison to good? We don't know. This isn't necessarily a one-unit movement between very good and good. Even when we say things like, okay, so poor is going to be worth 1, fair is going to be worth 2, average is going to be worth 3, good is going to be worth 4, and very good is going to be worth 5 whenever we go to look at the data. Even if we provide this scale, it's still impossible for us to know because these are just arbitrary numbers that we have placed here. It's not a scale that actually exists in the scientific sense. That very good or good is twice as good as fair because 4 is twice as high as 2. We don't know how these movements occur between units. We know the rank order of them, but we don't know how we move between these units. We don't know how the students are making that distinction. And because of that, these types of Likert scales are more accurately treated as ordinal scales. Okay, so those are the two major types of qualitative measures, are nominal levels of measurement. And you might want to pull out a piece of paper for yourself and make note of this. But two types of qualitative measurements are nominal and ordinal. So the two types of quantitative measurements are interval and ratio. And interval and ratio are very similar. In fact, there's only one real difference between them, and that's interval levels of measurement do not have a meaningful zero. They don't have a true, real zero. And so examples of interval levels of measurement are scales where we know how it moves between the units, and we can make meaningful distinctions to say that if you have 10 on a scale versus 5, that is twice as high. But if you have a 0 on that scale, it doesn't mean it's the absence of the quality. And so example would be IQ test. So you can score a 0 on an IQ test, but that doesn't mean that the individual has the absence of intellect. That just simply means you have the 0 on that scale. A 0 on an IQ test doesn't mean absence of intellect. Another more tangible example would be if you think about temperature. And so if it's 0 degrees outside right now on the Fahrenheit scale, it doesn't mean that there's the absence of temperature. There is temperature. It's quite cold. You'd be able to feel that. It's the freezing point is what it means. And so in that sense, on a thermometer measured in Fahrenheit, there is no true 0, because to be a true 0, it has to mean the absence of the quality. It does not exist. Ratio level data, though, does have a true 0. And so since it has a true 0, we know that if 0 is shown, then it means that the quality didn't exist. So an example would be height or weight or age or money. Any of those scenarios, while in theory it might be difficult to think about, if you were to has a true 0. So if you were to think about, weight, height, age, money, if you weigh 0 pounds, if you're 0 inches, if you're 0 years old, or you have $0, in any of those sort of scenarios, theoretically, if you weigh 0 pounds, it's the absence of weight. If you are 0 inches tall, it's the absence of height. If you are 0 years old, it's the absence of age. If you have $0, it's the absence of money. And because of that, it's a true 0 describes the absence of quality. So to recap, there are two basic types of quantitative measurements. There are interval levels of measure. It's precise differences. If you think about the difference between interval level and ordinal level, it's precise differences between units of measure. But there is no true 0 in interval level of measure. In ratio level, very, very similar to interval level. It's precise differences between units of measure, but there's a true 0. So just as we've done before, I'd like to let you review each example below and think about if it's qualitative or a quantitative measure, and then what level of measurement or what type of scale is it using. And so Once again, if you want to make quick notes for yourself so you can reference it as you review these, it would be qualitative measures. You can have either a nominal or an ordinal scale. And with quantitative measurements, you can either have an interval or a ratio scale. So pause the video, provide those answers for yourself, and you're ready, press play, and we'll review them together. All right, welcome back. So eye color, we already discussed eye color, so this is a bit of a give me. But eye color is going to be just like gender or race or ethnicity or any number of state of origin or any other thing that you could measure that would describe a quality or the possession of a quality in a yes or no scale, but it doesn't describe you how much you possess of that quality. And so blue, brown, green, hazel, that is going to be a qualitative measurement, and it is going to be on the nominal scale because you just possess the quality or not. Rating scale, so this is our Likert scale example again. So poor, good, excellent. In that scenario, it's going to be a qualitative measurement, and it's going to be an ordinal scale because, once again, there's not a precise difference between poor and good. We can rank these in an order, but we can't say what is the movement between poor and good or good and excellent. We don't know that information. ACT score is going to be a quantitative measurement, but it is going to be an interval scale. So it's similar to an IQ test in that a 0 on the ACT doesn't mean that the individual does not possess any quality of readiness for college. It simply means that on that level of measurement, they scored a 0. It is not the absence of a quality. And so it's going to be quantitative and interval. Salary is income. So you can have a 0. You can have a $0 salary, which means you have no salary. It's the absence of salary. That is a true 0. So salary is going to be quantitative measurement on the ratio scale. Age. Age is also going to be a quantitative measurement on the ratio scale, and it works the same way as salary in that, we never think of being 0 years old, but certainly if someone was 0 years old, that would be the absence of the quality of age. So that is theoretically possible, and so that is a true 0. Ranking of high school football teams is a little tricky because we have numbers, and we'll also talk about, and we sort of, colloquially think about that a team ranked 20 is, maybe like twice as low as a team ranked 10, but it's not really used that way. And so what a ranking of a high school football team is a qualitative measure on an ordinal scale because it rank orders them for us, but there is no precise difference between 1 and 2 and 2 and 3 and on and on and on. And so if you want to use a more practical example from right now, we could go to ESPN.com. And we could look at the college basketball rankings. And Kentucky is ranked number 1, and Virginia is ranked number 2, and Gonzaga 3, and Villanova 4, and Duke 5. And if we look at these rankings, we know which order they stand in according to the sports writers, but we can't necessarily say that Kentucky is twice as good as Virginia because they're higher, or Virginia is twice as good as Villanova. That's not a meaningful distinction to make. We don't know how the movement between these occurs. Kentucky may actually be 10 times as good as Virginia, but there is no way to move them beyond in this sort of rank ordered fashion beyond 1. So 1 is just the highest ranked order of where they stand. So ranking of high schools is going to be qualitative, and it's going to be an ordinal scale. Nationality is going to be just like eye color. It's going to be a qualitative and a nominative on a nominal scale because it describes the possession of the quality of being from that nation. But once again, you wouldn't be able to make any sort of statements about more or less possession of a quality. You either are from or you are not from whatever nationality you have. So temperature is going to be, this is actually a little bit of a gimmick because I discussed it earlier, but it's going to be a quantitative measure, and it's going to be on an interval scale because there is no true 0. If you have a 0, it does not mean the absence of the quality on the Celsius or the Fahrenheit scale. Zip code is very similar to Social Security number in that it uses numbers, and so we might be tricked into thinking that it's quantitative, but it's in fact only qualitative, and even beyond that, it's only a nominal scale in that qualitative measurement. And the reason why is because it only describes essentially putting a label using numbers to an area. And so it says that I am either from or not from that area, but you can't reasonably make any other statements about what does it mean to be not from or from that area, other than to say that I either am or I am not. And so in that way, it only names me as a member of that area or not as a member of that area. So here's a quick little overview to be able to keep track of what is the level of measurement or the scale being used, and what is the data type, and how finely is that data parsed for quantitative measurements. And so if you want to take a moment just to review this for yourself, that might be helpful. But there's two types. There's qualitative and there's quantitative data. And within qualitative data, you can either have a nominal or an ordinal scale. There is a quantitative data type, and that can be finely parsed into either continuous, where it goes beyond the decimal place, it's not discrete units, or into discrete, where it is discrete units. And so it's more countable data in that way. And you can also design your surveys, as we previously discussed, so you decide whether it's going to be used as discrete or continuous data. Beyond that, in either format, you can either have interval or ratio data, and really the distinction there is, does it have a true zero? Does zero mean that it's the absence of the quality? Okay, types of descriptive statistics. So we're not going to review all these in this video with you, because we're going to review some of these in class, but I do want to highlight the few that you're going to be more likely to use for your SPSS projects, and the one that we're going to show you how to do on SPSS when you perform initial descriptive statistics. And so the first ones are measures of central tendency. And the major ones that we think about are mean, median, and mode. And mean is just the average of the scores in a distribution. And so if we think about the kind of math that we would do in elementary school, we certainly probably all of us found the mean, median, and mode. I'm not going to review these in too much depth with you, because the next video that I'm going to have you watch from the Khan Academy will specifically review how you find these. But the chief difference, very quickly, is that mean is the average that you use to find. And so you total up all the different observations that you have in a data set, you divide that by the number of observations in that data set, and it will tell you what the central point in the data is. And so a nice way to think about it visually is that mean is really a scale. And so it's putting it's putting the lever in the middle, and so that all the data will be balanced on either side of that scale for the mean. Median is really what is the middle point of the data. So if you were to line up all of your data observations from the absolute lowest, smallest observation to the absolute highest observation, what would be the middle point of the data? And so it looks at each one as an individual unit. Median data can also be useful whenever our data is likely to be skewed positively. And so an example would be with positively or negatively. So if it's going to be overweighted to either really, really large values or overweighted to really small values, which are going to give us a distorted picture of what the central tendency is, you're more likely to use the median. And so a very common example of the median, where we see it used, is with family income. So you'll often see reported median family income. And the reason why is because if they were to include billionaires into that and find the average, it would drastically skew the data to make it look like the average family in America is far more wealthy than they really are. So by using the median, you're able to say, well, this is the middle point of the data, and it doesn't provide as much weight or allow those billionaires to skew the data to a much more positive trend. Mode is simply what occurs the most often within the data set. And so mode can be useful whenever we have multiple areas of central tendency. And so if you'll have where the data isn't necessarily clustered in a normal fashion, so bimodal distribution. So in examples where we have a bimodal distribution, so where the data is not necessarily clustered in the middle, a mean is going to provide sort of an inaccurate picture, because it's going to make the individual think that most of the data is in this point, because the data would be weighted on either side, but that's not necessarily accurate. Likewise, a median would likely give you the same sort of picture, which isn't going to be accurate. And so if you have a distribution that looks like this, a mode might be a better representation, because it'll show us that it's either going to be whatever this observation is or whatever this observation is that occurs most often in our data. So measures of spread or dispersion, they basically describe how our data is spread around that measure of central tendency. So the one I really want to focus on, and I'll review them quickly, is range. Range is basically the difference between the highest and the lowest score plus 1. And so it lets us know what amount of data is captured between our lowest and our highest score. The deviation from the mean is the score expressed as the distance from the mean. And so if we know our mean is 4, we can say that 6 is the deviation from the mean is 2. And so that lets us know how far does each score leave or spread out from the mean. Variance is the sum of the squared deviations from the mean divided by the total number of scores in the sample. And standard deviation is the extent to which scores in a distribution on average deviate from the mean. And so each one of these we'll see reported out. I don't want to review these too much because I don't want to confuse the matter, because we're going to discuss deviation from the mean, variance, and standard deviation in class more in depth. But for range, you are going to have to find it. And so I do want to briefly review range with you because it's not going to be covered in the con video. So range, really quickly, let's say that we have the scores of 4, 5, 7, 9, 10, and 11. So we would need to put these in order for ourselves. So we'd say 4, 5, well, it's already in order, 7, 9, 10, and 11. And we would subtract our lowest score from our highest score, which would give us 7. And so our range for this one is 7. So the calculation of range is really just that straightforward. There's not, frankly, that much to it. Measures of relative position, that's where you see things like percentile rank or standardized score. And so it lets someone know where you stand in that rank order. So if you're in the 87th percentile, it means that 87% of individuals who took whatever that assessment is scored below you, and you scored at the 87th percent. So that's where you stand within that rank. And the measures of relationship are where you see things like correlation, correlation coefficient, coefficient of determination. And really what these measure are how much do two different types of observations vary together. So how much does adjustments or changes in one variable affect adjustments or changes in the other variable? So once again, don't need to really concern yourself with most of these, really only concerned with measures of central tendency or range. So what does this all mean? It really helps us figure out how we want to best represent our data. So with qualitative data, which is either nominal and ordinal, the best way to represent that data is using either percentages or using the mode. And the reason why is because we want to be able to meaningfully discuss and show how that data is presenting itself to us. And so with percentages, you might have, if we want to go back to this example, just saying 10 people identify as male isn't necessarily helpful, because is that 10 out of 20? Is that 10 out of 30? Is that 10 out of 40? Is that 10 out of 50? That is a very different thing to represent depending upon how many people are in the class. And so representing each one of these by percentage would be far more useful than representing each one of those simply using the count, because we don't really know what that means just in a vacuum. The mode, likewise, can also be useful because it can tell us which is the response that happens most often. And so for this example, the most often commonly cited gender identities are male and female. And so the mode can still be useful for this sort of ordinal or nominal data. Quantitative measures, we would want to use measures of central tendency, because which could be mean, median, or mode, depending on how your data is being represented or being presented to you. The reason why is percentages aren't necessarily useful, because if you want to think about an example where we have, let's say, height, we might have 30 observations, and we could have everything from 64 inches to 65.5 inches to 67 inches to 61 inches to 72 inches, and on and on and on and on. So knowing what percentage of people are at 72 inches isn't necessarily very helpful for us, but being able to say what the average height is, so what the mean of these heights are, or what the median of these heights are, is going to be a far more usable representation of this data for the users if you're trying to describe it. And so the chief difference here, and what I really want you to think about as we start to move forward, is what's the most meaningful way to represent your data? The only reason why it's really important to think about and to know whether you're using nominal or ordinal data, what types of measures that you're using, is because it helps you figure out what makes sense to represent this data. And so that's going to conclude this short video. Now the next one for you to watch will be the Khan Academy on central tendency, and then we'll have another video for you to watch about how to do some of these initial descriptive statistic functions in SPSS. All right, thanks.